solely from the equations. So finding our maxes and mins. So the process we did yesterday was finding all the critical points. What are critical points? When the derivative is 0 or undefined. And then we tested the endpoints and those critical points, plugged them into the original equation, and the highest value was your max and the lowest was your min. Now this gives you the absolute max and min, it does not give you the locals. But that was our emphasis yesterday. So today we're just going to be finding the absolute maxes and mins of these equations. So for this one, to find my critical points I have to do the derivative, so it might be easiest if we first distribute. So 3/5 x times 30 give us an 18x. 3/5 x times negative x would be negative 3/5 x squared. Then we need our derivative, which would be what? Okay. Is this ever undefined? No. You have to worry about the undefined if you have like x in the denominator. So if you have a negative power on your x, you need to worry about that. We don't, so we just need to figure out where this is 0. So I'm going to take each side times 5/6. (18 divided by 6 is 3, times 5 will give me 15. So x equals 15. That is my critical point, and that is the only critical point we have. We are testing on the interval 0 to 30. So we're going to plug in 0, 15, and 30. Let's see if we can do these without a calculator. Let's practice. If I plug in a 0, you just put 0 into the original, what do you get? 0. What happens if you plug 30 into the original? Right. So you have 30 minus 30, which is 0, times anything is still 0. If I plug in a 15, then I have a 3/5 times 15 times 15. And so 5 goes in 15 3 times, so you end up with 9 times 15. 135. So where is my max? After 15 equals 135 is my max. And how many mins do we have? We have 2 mins. It's the same value, so we have 2 of them. So if they're polynomials, it's not too bad to find. Like example 10 is just another polynomial, so it's going to be very straightforward like that. Let's look at example 7, when it's a fraction instead of a polynomial. First question, is there any way to write this so it's not a fraction? You could put this as a -1 power, but it's not going to really help a whole lot, is it? You know, if it were just a single term on the denominator, we could simplify it, but because it's 2 terms, we're really just going to have to deal with it. So to do this derivative, we have to do the quotient rule. Spin a little bit. So quotient rule is low, so the bottom, d high, what is the derivative of the top? Minus high, d squared, d low, derivative of the bottom, over the low squared. We need to clean this up, so we're going to distribute the 6t through the top. And gives me a 6p cubed. What happens? So we are left with 24p over p squared minus 4 squared. Negative 24p. We need critical points. Critical points are where this derivative is either 0 or undefined. What would make it equal 0? If you just set this equal to 0, you'd multiply your denominator over and it goes away. Divide by negative 0.4 and you get p equals 0. So 0 is a critical point. This thing is undefined if your denominator equals 0. Yeah. So that's when p squared is 4, so that's if p is positive or negative 2. So we have 3 critical points this time. It only equals 0 once, but it is undefined twice. So we get a total of 3 critical points. So now, I did not give us, actually I didn't ask for maximum and minimum on this one, I just asked for you to find the critical points. So we're done. I didn't give you an interval to test. So I just wanted to make sure you could find those critical points when you had fractions. If I wanted the actual maxes and mins, I would have to give you some kind of interval, and then you would test your critical points and your endpoints. Now, one thing that I want to mention, if I said like the interval 0 to 3, would you test all of your critical points? No, you wouldn't use the negative 2. So watch out. You might get critical points that aren't included in the interval I give you, in which case when you go to find your maxes and mins, you just ignore those. You only use the ones that fall in your interval. Okay. How are we doing? Should we try another one? I want you guys to try example 9 for me. We did one similar to this yesterday. Why don't you give that one a shot? Looks like you guys got the derivative, but then you got stuck. So there's your derivative. We got to this point. A couple options for moving forward from here. We could factor out the greatest common factor, which you would probably do very easily if I gave you like an x to the 5th and an x cubed. Then you can factor that out, no big deal. It seems like the negatives kind of throw you a little bit. You could also, if it helps, write this as a fraction. We know a negative power just drops it to the bottom. This would be like a 5x to the 2/3 over 3. And we're trying to figure out when this is 0. First of all, is there anywhere this is going to be undefined? Yes. Where? 0. Because x is in the denominator, we know the denominator can't equal 0. So first of all, we know right now x equals 0 is a critical point because it's undefined. Let's figure out when this equals 0. So if I add this term over, cross multiply, that would give me a 15x. When you multiply, you add those exponents. 1/3 plus 2/3 is just 1. Equals 30. Divide by 15 and you get 2. So my critical points are at 0 and 2. Do both of them fall in the interval we need? Yes. So we have to test -1, 0, 2, and 4. Okay, I'm not sure that all of these are going to be nice numbers, but we can work through them. If you put in a -1, a 2/3 means the cube root of -1 squared. What's the cube root of -1? -1, and -1 squared is 1. -1 to the 5/3 means the cube root of -1, so -1 to the 5th power, which would be -1. So you get 5 plus 1, which is 6. If you put in a 0, 5 times 0 minus 0 is 0. And now they're going to get a little uglier because you can't do the cube root of 2 exactly. So let's use our calculator to plug in the 2 and the 4. When I put in 2, we get 4.76. If you put in a 4, we get 2.5198, so 2.52. So then, what's our absolute max? And our absolute min? Is that 0? Okay. Everything's going okay? I think I'm going to stop here. And I have a handout for you. I just want you to practice finding your maxes and mins.